so it's a good time.
Yeah.
Okay.
Okay, thank you very much for coming to our last data science in my talk. So we have all these snacks and we even have a pizza, so feel free to enjoy. While you are eating, I want to introduce our guest speaker, Laura Veta. So Laura actually is graduate from IU, so it's our alumni. So yeah, she is very pioneer. She's VP of analytics at the Kinney Group, and she is one of the most influential leaders at the company. So is this your own company?
No, it's not my own company. Yes. I wish, maybe later.
Yes. He's our data science student. We're going to bring the company together. After graduating from IU back to 1997, Laura built a professional foundation in database and software engineering. Fast forward to today, Laura is a Splunk certified consultant. So Splunk is, yeah, everybody know this company, so I don't need to even talk about this. She also holds a CompTIA Security Plus certification. She has been a critical driver of Kinney Group's technical capability and has written numerous customer success stories. And her combination of nature, intelligence, work ethic, and expertise has earned her tremendous respect from customer, partners, and colleagues alike. So now let's welcome her to talk about the Splunk. What is the Splunk setup and the?
Well, I'm just gonna start here just to tell them what Splunk is.
Yes, Splunk and the machine data.
Yes.
Right?
So Splunk last year came out with a machine learning toolkit, which is really what I'm here to talk to you about. But I'm just gonna level set and make sure people know what Splunk is. Has anybody heard of Splunk? Okay, a few people have. So Splunk is really a way to manage a data pipeline and allow you to visualize it. So Splunk can take in any type of machine data. It really can take in any type of text-based data. So most of these data types are text-based. Windows event logs actually aren't text-based, but Splunk it provides a little plugin that converts it to text so that Splunk can ingest it. So it can connect to databases, and allow you to correlate against that. So that's useful a lot of times because customers a lot of times in logs show up as an ID number, and it allows you to then correlate it that log record means that customer. So Splunk can bring in data either via syslog or with forwarders. So it has forwarders for Windows and Linux. Then it goes to an indexing layer right here, and that's where the data is stored. Data in Splunk is stored a lot like Hadoop. So it takes in all the raw logs, compresses them by 30%, and then it has metadata files that right across the top of those that tell you which buckets contain what types of data, so what fields are in each bucket. So then when you search, it basically is a pointer into that. So what Splunk is really, really good at is time series data that's high volume, high velocity. So if you look at the buckets in Splunk, they all have a beginning and ending timestamp that's in int time. So if you're looking at a certain discrete section of time, say like the last 10 minutes, which is frequently what people look at, it'll know exactly which buckets to look in just based on that, and then it uses the metadata to say, okay, the fields you're looking for are in or are not in that bucket. It knows whether to, they call it blowing them up and then looking through them. So then it has another layer, which is their search layer, so you can scale these separately. So you really scale your indexing layer based on the volume of data going in, and typical ingest rates are 100 gigabytes would be a pretty standard install, 100 gigabytes per day, daily ingest. 2 petabytes a day is the biggest customer. A lot of times we see like 4 terabytes for big enterprise customers. So it handles a lot of data, and you still can search on it really, really quickly. So this search layer, you scale it based on the number of searches you have or the number of automated searches you have scheduled. So a lot of the Splunk apps that are out there already have pre-built searches that basically reach into what is really a data lake and pulls out the things that you want to see. So because of that, you can have automated alerting. You can even have automated remediation, has workflows built in so that you can have things that happen. So Splunk in and of itself is a powerful tool for security use cases, IT operations use cases. Those are the sweet spot. So they've been trying more and more to get into the Internet of Things and business analytics, and a lot of that has uses in machine learning. Machine learning also has use cases whenever you have a large volume of data that you want to understand better. So they've even integrated it into their flagship products for enterprise security and IT operations. And I'll cover that a little bit, what they did with that. So I'm just going to click through some screens so you kind of get an idea of just what Splunk looks like out of the box. So let's look at this. So Splunk really can give you an overview of stuff that's going on in your environment. So it'll tell you, basically, I'm looking across your whole environment, and I'm looking for a whole long length of time and what's going on and how does it look against normal. So let me just click through some of these. Here you can see it can calculate averages. It can tell you what normal looks like, and then it can tell you what's happening right now. So for large environments, even understanding what normal looks like, if you don't have a tool that does big data analytics, it really is anecdotal. Like someone will tell you if things seem normal or if the revenue coming in seems normal. So you're really getting more of a feel versus Splunk can tell you like, well, by time of day, day of the week, day of the month, this is what your normal looks like. So are you normal? It can tell you yes or no. So I'll just click through just real quick to show you some of the visualizations. And to build a dashboard like this, just so you know level of effort, it would take somebody like me who's trained about 2 hours to put something like this together. So it's not like it's a big bucket of time to put this together. It's really, you put a search string behind it, and then you put a widget in front of it. So it's pretty simple. Splunk is really good at telling you. So a few years ago when we used to demo Splunk, it was a huge deal to be able to see multiple machines showing up in the same time series. Because for large environments, I remember we sold Salesforce maybe like 4 years ago. And back then it was ExactTarget. Are you guys aware of that, what that company does? So they had so many servers that even finding out like if one of them had a memory leak, they'd have to log into each server and figure out like who is it? We don't know who. So there's a lot of other tools now that have come out that bring that kind of like consolidated visibility in. But it's still pretty easy to see all of that across one graph, and it's really a powerful data point to be able to do. So I think that's, I'll show you the CEO dashboard. So a big thing that we do as consultants is, I don't know why it did that. Is show people, you know, what is the business reason why you would want big data analytics? Well, a CEO would really want to know, you know, how is the activity on my website rolling up into dollars and cents and just activity in general? And also, you know, how does the number of visitors I'm seeing comparing to what I would call historical trends? Obviously, for security reasons, there's lots of use cases that have to do with, I want to geolocate where my traffic is coming from, but it also matters for ad campaigns and the way that you reach your customers. So I think especially with the data science major, realizing that when you guys are out in the workforce, people really only care about the business drivers at the end of the day. So you have to be answering a business question with the work that you do. So I'm gonna go ahead and switch now to the talk that I typically give on machine learning, and then I'll get really as deep as you guys want, as I'm able to, into the machine learning app. So last year I splunked an IndyCar. I actually splunked 3 IndyCars that did the Indianapolis 500 for the 100th running. So this talk is a little bit about what I learned while using that talk. And that was the first time that I had ever used the machine learning app for Splunk. It's so much data and the questions are so complicated that I worked with a lot of the data scientists at Splunk to try to figure out how would you use a tool like that to answer questions that before would have been pretty much unanswerable. So I'm going to buzz through this. We're a company in Indianapolis that does analytics, and Splunk is part of that. So I'm going to talk about the 4 IoT use cases that I have seen in the wild. So we've done engagements on them, or I've talked to customers about them. What do they want to do? And I'll also talk to you about things I learned about the way Splunk is architected that matter so that even if it's not Splunk, if you have another product like that, you could say that this matters. So the factory floor use case. So people want to do real-time inventory management. So Eli Lilly, for instance, for their factories, they have spares at each factory site. So they have 2 spares for every single part. Well, that's really, really expensive to have that kind of inventory that's not in use, that's just sitting on the shelf waiting for it to be needed. So what they wanted to be able to do was consolidate their inventory down to regional sites where they'd have 2 spares at each regional site, and then they'd be able to do predictions so that with, hopefully 4 hours before the part failed, they'd see evidence of failure and they'd get the part to the location before the failure actually happened. So by using things like machine learning to make a real predictive model, because it's really hard for people to tell what causes a failure. Obviously, if you can get an error code off of something, that's dead easy. They wouldn't need any of us to figure that out. But it would be more like, what can you tell about the temperature that it's run at for years? What can you tell about when the other things around it have failed? What has gone into that? What can you tell about the manufacture date, where it was manufactured at? How long it was set on the shelf before it actually went into service? How long was it in service? So you need machine learning really to figure out what mattered in the whole question. And then you can put predictive analytics in front of that to say, well, let's watch for that. And when these things happen, then we'll know that we should get a part to that location. So line pacing problems. So this is an interesting one that we actually talked to Procter & Gamble about because they wanted to know when things started to slow down in their line. So when things in their line that would impact their business happened, I would say that one of the things we felt would matter is when things slowed down. But really, they want to know when something happens in the factory line that's going to impact their revenue. That's the business question. So we thought, well, maybe when things slow down, or maybe when they speed up, or maybe when at a certain point they're faster or slower, that would matter. So I actually talked to a guy that is another consultant for another company, and he is much older than I am, and he was really high up in a business that had a bunch of factories for years. And he said what they would do is they would have like a couple of 60-ish-year-old women that had been at the factory forever, and they could tell them when things were going bad. Like these women just had like a sixth sense on what was going on. Well, that totally works while those women are still working for you. But once they leave, you need something that will tell you when things are off pace. So these are all emerging things that companies are just now starting to try to use big data or machine learning to answer questions about. So having knowledge in these kind of areas is going to be a big deal. So one thing I've been over the past year just even trying to answer in my own head is, okay, I know how to do a big data tool and I know how to do analytics, and because someone showed me, I can kind of work my way around data science and machine learning. But I'm not a factory worker and I've never worked in a factory, and so I don't have that kind of domain expertise. And I've never manufactured parts that go into a factory, and I've never had to manage an inventory system. So the question is, like, you have these domains of expertise. I'm an IT domain expert. There's also domain experts in factories and race cars and all these other things. And then there's also business domain management. They know what the business needs are. They know, maybe they're on a leadership team or something. So if you could have all of these knowledge sets in one person, you would just like rake in tons of money and have tons of work. But you never really do. So a lot of the struggle that you have is about bridging the gap of figuring out how to talk to people that you don't even talk the same language usually when you first meet each other. So I'll talk about what I learned about that later. But what I've really been wondering is, would it be better to form a team with people that have these different types of expertise, so that one of them has the big data, data science expertise, the other one has the domain expertise for the things that you're going to go try and pursue and solve. So that's just something that I've been thinking through. So productivity assessments, this is kind of, you could figure out what makes a productive employee either on a factory line or in a business in any way. One thing that we talked to Procter & Gamble about, which was I think they did end up using machine learning to do this, but we really just taught them how to use the tool that I'm going to show you, and they did it themselves. But they wanted to know, for a change that went into their IT infrastructure, what created like a broken change or what created a good change. So they were anecdotally saying, we don't know if it's the length of time that it's in their change management process. So the length of time that it's really in their approval process. Is it worse if it's in there for 30 days because like people aren't watching it and other changes are going in the system while they're waiting? Is it worse if it's real quick because everybody's just like, jumping the gun? Are Bob's changes always terrible? Does it matter if there's 3 people on the review board or 5? So they use the machine learning app to answer those questions to make it where their change management process was ultimately better. I kind of talked through that already. So what a tool like Splunk is really good at, and really any tool that you would use like this, is to tell you what matters right now. Because in a big business at scale, like the names that I popped out, there's so much happening that it's really hard to know what to look at, and especially to look at before something bad happens or before your customers or your revenue is impacted by it. So just-in-time inventory sparing. So I'm actually going to talk a little different than what this slide shows. So one place that we went to, they wanted us to help them figure out like downstream, where are all their parts, so they would know when they could make what they needed, because they would have the things that they needed. So they wanted us to reach all the way down into different distributors and really tell like a big data story of like the whole pipeline that becomes a part that the company needs. But the thing about Splunk is it's not ACID. So there is no transactional consistency. You can only do it later on the back end. You can do some checking to make sure that everything happened in queue. So there's a lot of other things that you could use that have transactional consistency, like you could put Kafka in the equation. I've been kind of trying to think through how to get this transactional consistency, because Splunk is a great tool to tell that story because it's so easy to visualize things. But that's when I mentioned earlier that no matter what tool you're using, when you look at your problem, you need to be thinking like, does it need to have transactional consistency? Because a lot of the big data tools you end up working with don't have transactional consistency, and it needs to be something that you think about, whether you can have it on the front end or the back end, or you can get away without having it. So with this just-in-time sparing, what we found by going to different clients is when a part goes out, a lot of times all the parts like that go out really close in time. So it makes end-of-life issues really hard because they really only keep a couple on hand. So with how fast things happen at a factory, it can be a big deal. So a lot of people want to know what factors determine the root cause of failure. And then how to best approach the problem. Like how can you tell by what's happening in real time how to best approach a problem? So we do a lot of work with drones for the US Army. And one of the questions they have is when they lose sight of a drone, they want to know if it's because the drone broke or because they just lost line of sight to the receiver that's getting the data. So by having analytics and machine learning on the front end, you could start to say what causes a drone that really broke, versus what causes a drone that just lost line of sight. People get out of bed for this stuff at like 2 o'clock in the morning just to find out 20 minutes later that it was no news at all. So it's actually a big deal for like quality of life for people that deal with that stuff. So I'm not going to go super into this. There's a lot to cover. So sports analytics is what I did for IndyCar. So one thing is to have the right tool. So Splunk's really good at this time series data that comes in really high velocity. So it's really good for things like racing because that comes so fast. But I don't know how good it would be for things like baseball that's a lot slower. The only good thing about baseball is the sport's been going on forever and people have been collecting data for years and years. So you do have a high volume of data that you could collect on. So I think when you're looking at the tool that you use, it really matters that you have the right type of data that's really good for that tool. So look at the architecture underneath how the tool's made and make sure that it matches what your data is. So with this, and if you guys get into IoT stuff, the way people have collected in the past, it makes it really hard. Like everything that they do was all hex. So we had to do tons of hex conversion. they had characters that Splunk couldn't read, so we had to do character conversion on the front end. So we had to do a lot of little programs on the front that we don't typically have to do to make it so that Splunk could even read the data. And this is where, so when I worked with the IndyCar team, those guys were so smart. They're awesome at figuring out how to position a car. So what really matters on the car is what the downforce is how sticky it is to the track. So the stickier it is to the track, when they go through the corners, they can take on higher Gs and not flip off the track or just fly into a corner. So what they do is they look at the temperature of the track and they adjust basically the downforce at all 4 points to try to make it as sticky as possible. So one of the main things they want to know is what's the track temperature going to be. So that's one of the things that we did try to use Splunk to predict with, and the machine learning app with varying results, which I'll kind of talk through. Yeah. But when we first talked to them, they really didn't know what a big data tool could do or why they cared about it. They're really good at what they do. They had really good success before we showed up. So they were like, what can you do that would help us? So a lot of it was finding use cases that mattered. The first use case they asked us to look at was they had a bunch of spreadsheets that had driver comments for all these runs. And then they had all the telemetry coming off the car for each run. And they wanted to know if the comments that the drivers had, like there's oversteer in turn 2 or understeer in turn 4, if it matched what the data said. So we did a bunch of correlations and detection to tell across this big set of data were the driver comments reliable. And they were really reliable. I think we've just found 1 or 2 instances where we couldn't find in the data that it matched. It was super reliable, actually. There's so much stuff in racing that's completely untapped. So the data feed that comes off the track, it just doesn't have a lot of roll-ups in it or things that the team needs to know. It'll tell you how far you are to the next car, but it won't tell you how many cars are in front of you, because that really matters for what your wind resistance is and what the effect of the tow is. There's stuff about like, what's the difference between one pit stop and the next and what your performance is in each turn that would really be impactful to know, was it a successful pit stop or not a successful pit stop? So there's a lot of things that we absolutely can do and we're trying to do for this season. This season, I'm trying to Splunk the whole season. Last year, I just Splunked that one race. So we'll get a lot more just by Splunking a lot of different races with a lot of different course types. So you guys probably know what IndyCar is. So I gave this talk in Vegas last year, so people didn't know what it was, so I had to talk through it. So I talked a little bit about working with non-OT domain experts. So in the end, they were like, we just want you to totally redesign all the tools we have. Because what they do in the pits is they have 6 guys that stand around a cart, and they each are looking at a different tool, and they're telling over the radio what they're seeing to the main guy that stands at the front. And he's collating all of that in his head and doing all the correlations to decide what changes to make on the car. So you have one guy that's looking at the engine, the metrics coming off the car. You have another guy that's looking at pacing of different cars going around the track. It's unbelievable that they're as good at what they do with really, they're just each using point tools, and then a guy in his head is making all the correlations really with his own experience in his head, and they're going, 149 miles an hour around the track. So it's pretty unbelievable. So we introduced the machine learning app on this. So the first thing that they said is we would like you to try to predict the weather. So we used the machine learning app and we threw in all of the historical weather that we could get for the month of May. And we took all of their truck data that they had seen, and then we tried to predict what the weather would be based on, like, if you look at NOAA, that's the National whatever Weather Authority. They'll tell you like 4 or 5 data points of what's going to happen in the future. And so we would build a model based on all the historical stuff that we had, and then use the 4 points to try to predict the weather. Anyway, it was not easy to do. It really didn't work out. And what we did is we could not get a linear regression model to work. And we were like, well, we can't get the model to work. So some of the data scientists at Splunk were like, well, we'll just try every model we have until we get one that works. So they ended up doing a random forest model, and it worked, but it did not give a good prediction. So it fit, but it was not effective. So what I learned, and I think they also learned from that whole experience, is that you have to apply logic to what the data should be shaped like. So weather data should be shaped linearly. It's, heat goes up, different things go up and down. If you're having to use a random forest to do it, you really have to check yourself and think, should the shape be linear? Because there's other reasons why you can't get a model to fit. Either you don't have enough data or you don't have the right data points to really make a model. For predicting the weather, I don't know which one it was. It was one of those, but definitely the random forest generator did not give us good predictions. So the other thing we tried to predict was track temps. So based on the weather data we had and all the historical track temps we had, which we only had 5 years for probably 15 days in May of track temps on all 4 points of the track. Plus we had all the weather data off the truck from the team. So the truck's at the track, same location. We knew what the track temps were. So we could not get a good model to fit, and we figured out finally what the reasons why, because we asked somebody who'd been in racing a long time. So can you guys think of what the only thing is that really matters and what the track temp is? What's the only thing that would matter?
Precipitation?
No. Amount of sunlight at that spot. I know, that's what we were like, oh, you have all this weather data. You've like tons of weather data. And the only thing that mattered was how many beams of sunlight were hitting the place where the sensor was. So we did not have that data point. So we could not make a good prediction no matter what kind of machine learning model we had. So that's what we really learned, is that you have to have the right data points. Also, we believed that because of barometric pressure, we could have made a really good estimation of cloud cover, but because we only really had maybe 115 days worth of data, that's not enough data points. If we had many years and every day, we could have probably used barometric pressure to get close. So it really matters how much volume you have. I'm probably preaching to the choir. You guys know all this stuff. So the run up to race day was pretty interesting because the team started just sending us their data from their runs and questions that they wanted answered. So one question that they had is, when should we do our trials, which like their qualifications, like what time of day? So the wind last year was really weird in May. The wind all came from the north, when normally the wind anywhere in Indiana, if you guys have been here very long, you'll know the wind always comes from the south-southwest all the time. Maybe sometimes in the winter it comes from the north, but usually it's always come from the south-southwest. So at the track, at the south-southwest corner, there are stands that are really high. So really, there's very little wind effect on the track. Well, last year, the wind all came from the north almost every single day in May. And at the north side of the track is a golf course, and there's almost no stands. So we did a bunch of analysis, and we did not use the machine learning app. We just did time series analysis and correlation between speeds on the track and exactly what the wind speed and direction were. So we really had 3 data points. And we were able to say that below 12 miles an hour wind speed, you could predict the speed. Like you could have reasonable ability to say that this is what the speed will be, but above 12, you could get anything. It could be fast, slow, you could not make a good prediction. So pretty much we told them that they needed to wait until the speed was below 12 miles an hour. And anyway, they had a really good run. A lot goes into it, so I can't take credit for anything, but they had a really good day that day. So race day insights. So when the actual race day happened, we actually got telemetry off the track. So on the track, there are what they call these loops. And so the car, there's like maybe 12 loops on the whole IndyCar track. The car goes over the front of the loop and the time is noted, then it goes over the back of the loop and the time is noted. The distance that it takes for them to get from one end to the other end of that loop is their speed. And it gives them a lot of information about, distance from other cars and all that, and IndyCar rolls all that up for them. So what we found out the day, we just start Splunking the day of the race, and we build all these dashboards just during the race. And that shows, how fast you can make that stuff happen. But the data comes so fast that without a tool that analyzes big data at that kind of volume, I don't know how you get through the race. That's why them standing around at the podium and doing that is just so unbelievable. So, does anybody have any questions about the race? I'm not going to go through the rest of the deck because it's pretty long, and I just want to show you guys the app. Yeah?
So it's fascinating, everything that you said, but I'm still struggling a bit. So what, you had mentioned that they can make adjustments. So like what's the actual impact? If they learn some additional information, what adjustments can they make during the actual race?
Well, they make adjustments to like how the fenders are, and they make adjustments really to the downforce at each of the four corners. And if they are too sticky, they're too low, and they actually will drag on the track.
Gotcha.
And if
So there's a sweet point that they're...
There's a sweet point that they're always trying to get to as a team, and really that's what we were trying to help them do. And the other thing that they really wanted us to do, so it's unbelievable that what the teams do to figure out if it's going to rain, because if it's going to rain, it's a big deal for your pit strategy, because if you think it's going to rain, then you don't pit until it rains, and then you pit and you wait and whatever. So if you think that it's going to rain, you treat things differently. So what they do to try to predict the weather is the teams actually send people out into cornfields around Indianapolis. They do. I'm not even kidding. Cornfield, lawn chair, cell phone, you let me know if it rains. So the team's big ask was for us to just Splunk the weather stations around there and tell them what the weather was. Like, was the barometric pressure dropping or rising? Was there any sign of rain at any of these locations? I know it's unbelievable. It's like the dark ages, but that's part of how they do things. So it was pretty cool to be involved in something where you had something that was just so different than what they were used to. It was just like a different world. Plus seeing how they do things, which is unbelievable. So, yeah.
Did you add the sunlight and sun angle sensors, because it also depends upon the sun angle, and sometimes they delay and it goes later in the day and the sun angle?
They have no way to collect that data. The only thing they collect is the track temps at the four corners.
You couldn't put a feed sensor in each corner and feed that in?
Well, we actually figured it out so late, but I doubt they'd let us put anything even remotely close to the track. They're so, like, they don't let last minute changes in. But I think that would be a good thing to collect.
Standing with a cell phone.
I'm going to take your name and get you at the track this May. Yeah.
Did they abandon the 6 guys standing around the car?
What was it? No, they didn't. So they cannot switch that kind of stuff up in real time. But they did start talking like we should think about doing that. But then we did not end up splunking the other races. I think it's something that is definitely wide open for them to do that kind of stuff. But it takes somebody time to build that kind of app, and we didn't end up doing it last year. Yeah, go ahead.
So what other types of data points are coming from the cars, and how are they getting and using that in the race?
Okay, so the data points so they come over these loops. Underneath the nose of the car, they have this, it's like a little cone. It's real small. And it basically tells them what time it goes over and stuff. But it also gives them like 6 to 8 data points. And it's like, what gear are they in? Are they braking? What is their steering at that point? It's like 6 data points. And then it's a couple things coming off the engine, because IndyCar is looking for signs of engine tampering because they want to make sure everything's level. So those are the types of things that come off the car during the race. But then they also send you a lot of stuff about what's happening in the pits, and they send it all to you in data format. So you can see a lot about pit strategy and how, who's fastest and slowest, even down to the millisecond. One thing that we thought would be great is if we could try to predict what causes a yellow flag. And that's something that machine learning totally is the only way you're going to get to, because there's so many things you'd have to throw in that pot to figure out what mattered. There's also other stuff about, when you make a pit change, what is the impact for your next run until you make another pit change? And then that would really give you like a success factor of that pit change. Was it successful? Was it not successful? So there's tons of interesting things. And the great thing about doing a use case like this is everybody understands driving, because most people drive. A lot of the other stuff I talked about, like the factory floor and real-time sparing, like, yeah, that's a revenue driver for businesses. And if you're in the business of making money, you care about that stuff. But most people don't really care about it. So, yeah.
General question, do you think doing analysis on transactional data is easier than a historical one? Like, the variation is consistent and it is lesser time to predict or something?
So the historical data, using the historical data was problematic because they end up making so many changes to the car kits year over year. So whenever you're looking at historical data, you have to think about what factors are you not being told that really do matter. Like we were told on the front end that they make a lot of changes to the cars, they make a lot of changes to the rules. So using historical data to try to predict speed and actually, so when we try to predict what the speed would be, we try to predict, can you predict the speed? Not what will the speed be? Because the car is too different year over year to say, and that's why it gets faster every year because they keep making changes to the rules and the car kits to make it faster. So. Okay, so now I'm going to get into the technical part where I show you how this app works. Okay, so this is the machine learning toolkit. So a lot of these things are going to look pretty normal to you, but I can tell you for an IT person, most of us never think about looking at our data in this way, and especially not being able to train and test a model when you have more than 1 or 2 data points. So what we've always done in the past is if you have like up to 6 data points, you really just want to think about it like, let's do a correlation. Let's look at it in time series all together and try to just make inferences based on the time series. But it's when you get a lot of data points that matter that it becomes a big deal. So here, this is a demo that they have that really teaches people how to use the tool. So they have all these, they have basically data about server power. So they're going to use a linear regression algorithm. They're going to try to predict the power consumption of a server, and they're going to use all these fields to do it. So total unhalted core cycles, cache references, disk utilization, CPU, so all these different fields to make the prediction. So here you're going to fit the model, and then once it's done fitting, it's going to tell you if you have a good model. I feel like the button's not working. There we go. Okay, so I'm not a data scientist, but you guys are, so I'm not going to try to act cool or anything. But when I was first shown this, you know, you want to see close grouping around these lines. You want to see a histogram that's really tightly packed like this. And you want to have a R-score as close to 1 as possible. Is all that true? Okay, because that's what they taught me when they taught me how to use it. Now, I have found models where I can get a really good R-score by playing with the fields, because I've played with this a bunch with a bunch of different fields. But the grouping would just be like all over the place. And then the model couldn't make a good prediction. And also, like, you can change the split for training and test depending on how much data you have available. So they default it to 50-50. Why would you go up or down on that? Do you guys know? Like, why would you want to do, like, say that you would want to do 75-25, where you train for 75 and test for 25. Would you ever want to do that?
Well, depends whether you want to overtrain or undertrain. Overtraining will overfit the data. Undertraining will be sloppier. If your data is sloppy, you want to be sloppy.
Okay, so is overtraining better?
No.
Okay. So how do you decide?
So there are many factors, but generally, we take like 70-30 or 65-35. It's the best, probably industry standard or something like that.
Okay.
It entirely depends on data.
Okay.
So hard and fast.
Do you think there's any kind of hard and fast about like how much data you want, or do you just want as much as you can get your hands on?
It should not be too much.
You can't have too much.
And it should not be less than it. There is a minimum amount of data that you should have for depending on the attributes and what you want to predict.
Okay. Do you think there's any, so what they told me is that it doesn't really matter how many fields I put in it, that if it doesn't end up helping the model, it just won't use it. Okay, because I always thought it was weird that they just put every single field you could possibly get your hands on, because typically when you do correlations, you actually think about what matters and only try to put those fields in.
By the way, there is one general rule that the number of fields data should be at least the amount of fields we are using. So if we are using 10 features, data has to be minimum of 10. It should not go less than the number of features.
Yeah, I think not having the right fields is a big problem, especially when you're looking at data like this. So that's where it helps to talk to the domain experts to make sure that you've collected all the fields. It ended up that we had tried forever to predict the track temps for like weeks. But when we actually got to the track and got to like talk to the old people that had done it forever, and they're like, well, it only matters how much sunlight hits the track. And we're like, oh, of course it does. But then we couldn't find it in our data set, so we really couldn't fit a model to it. So I'm going to go back to the showcase and show you some other ones that they have. So here you can predict categorical fields, which are like about predicting words and categories that fit something. And then you can also do it where you predict outliers. So let's do Bitcoin transactions, since that's about money. So here you can look at total events, and depending on what one you use, they used to have a nice graph where they would show you the outliers, but I don't see it in here anymore. So let me try one of the other ones that I've tried in the past. So we've had a lot of people that are in the IoT business want to use machine learning to understand their business better. So one of the ones we did, and I talked about this at lunch, was Elanco. So they do a lot of stuff around poultry. They use machine learning already to grade beef, and so they're adapting algorithms to grade poultry and pork as well. So let me see if this did better. No, it still didn't do but this one did give you some of the precision and accuracy scores. So let me see if something comes out different if I fit the model. So anyway, with this, you can use it to, make decisions about it. But one of the things they wanted to know is, when poultry moves down the line, what are the, in what instances, what are the outliers for, like, who has their wings left and who has their feet left when it comes to certain points in the line? So when you have those automated processes, having a tool like this that can use machine learning to help make predictions about, like, what your product is going to look like when it comes to the end can be pretty impactful. So those are the types of use cases that we've seen. So the other thing about this is just to talk a little bit about how it's architected. So this app is really architected by, they took the SCI Kit Learn stuff. So, what is it? Yes, scikit-learn, and they really wrapped it into the back of Splunk. So those are all the algorithms that you have access to. So here is a website that shows you like the classifiers, the regressors. These are going to mean a whole lot more to you. So do you guys want me to expand any of these? All this stuff? So they have all the clustering algorithms in here already. So they have a lot of stuff that's not covered by this that they want to get covered. So do you guys write algorithms that go in that language or not? Sometimes. Yeah, so I think there's a lot of ground that they would still like, the people that do this product for Splunk would still like to see covered. So that's something that I've been talking to Derek about, as how do we get you guys a list of things that could eventually make it into the product. And they actually have an API guide on how to plug something into the back of this. And it's basically all just in Python by writing a new algorithm and plugging it into the back. So Splunk is free to use if you don't have a lot of daily ingest. So it's something that you guys could download and play with and then write modules for. So I had talked a little bit at lunch to people about, data science has a lot of facets because you got to get the data to a point where you can even look at it. So Splunk is really good at getting data to the point where you can analyze it and manage the high volume of data that you have. So if you guys wanted to play with it, writing algorithms for it would be something that they would adopt because they want this type of thing happening. So, any other questions about Splunk? Any other questions about anything I talked about? Yeah.
I have maybe a stupid question. What's the difference between Splunk and Spark?
The difference between Spark and Splunk do similar things. They're a way to manage and work with big data. The difference I know of with Splunk is that when we go in and do an implementation with Splunk, we usually do it in about a week. So it's really, really fast to implement. Whereas with Spark, you usually have to have a team, a dedicated team, and it's usually a big team that manages all that data in that data lake. Now, if you're dealing with 4 terabytes a day, you probably have a team of 3 to 4 people that are managing that for you and building out things for you. So it's not that you don't need a team to manage Splunk. It's just that it's pretty easy to implement. It's a lot easier to train people to use the tool. It's not quite as specialized as Spark. Spark is really kind of developer heavy, and you have to be a really good engineer to work with it.
So this might be the competitor to Spark, and in the future, this platform might be able to replace Spark in the future?
I think Spark has some other things that this even can't do. So I think that they are not complete overlap tools at all. So I think that they have different things that they do.
I don't think Splunk tool has data integration and management,
I
DB
think
management,
they do, like
but
what I
Spark
talked.
does that,
Data integration and DB management?
like ETL or some database management systems.
No, it doesn't. It doesn't. It's not ETL based. It's not made that way.
It does have some data integration features.
It can integrate with databases, but it's not set up on ETLs.
And your backend is a MongoDB, right?
Well, MongoDB is part of it. So mostly it's at Hadoop base where it writes all the data down, compresses it, and then has the metadata on top. But if you're looking at things that is more like an organized list, you can put it in a MongoDB backend of Splunk, and then Splunk will access it that way. So it's another data repository that it has. It used to, before MongoDB, it just used flat file CSV, but they got too big and they were too unwieldy. So they stuck MongoDB on the back end maybe 4 years ago so that they could handle high volume of list data that had more of a known schema. So, yeah.
For all this visualization, what technology has been used in?
What is it?
For all this visualization, what technology has been used in Splunk?
Django, D3, D3JS, Django.
I was surprised. This tree is more academic.
Oh.
I was surprised the industry also used it.
Yeah, so D3JS and Django are the things that they use for the visualizations on the back end. And they keep exposing more and more of that to the front end where like somebody that doesn't know coding at all can just go start dragging and dropping and clicking on things. But you can access the whole D3JS Django library if you use JavaScript. You can access anything that's available on that. So, yeah. So Splunk is really good at time series, high volume, high velocity. It's not really great if you're just trying to plug into a database and visualize it because you have to know the search language, which is a lot like SQL. And really, if you're just going to hook in a database and do visualizations and you're not savvy tech-wise, you should just use Tableau or something like that. So, yeah. Yeah.
And you talk about Kafka, right? You use Kafka at the backend to take streaming data?
Yeah, so we're seeing, so I don't know how long you guys have been in tech, but a long time ago, we used to have to use like RabbitMQ and stuff as messaging buses to get things to talk to each other. And now this Kafka thing is here, and I'm like, wow, I wish we'd had that 7 years ago when we were trying to solve all these really hard problems. So we're seeing a lot of companies use Kafka as a messaging queue and a messaging bus. And I think I'm starting to wonder if it's a way that I could get kind of ACID-like things out of Splunk. But what we see it for is big insurance companies that want to send their log data to a bunch of different sources to be analyzed. They're using Kafka, and Splunk is one of the things they send it to, or their log management tool. And then they'll send it to other tools as well to be analyzed. So, yeah. So,
And yeah, Spark also has a streaming technology. Spark, if people don't use Splunk, they use Spark.
well, actually, if the big competitors, so for you guys, the big competitor of Splunk would be Spark. But for a lot of companies, big competitors of Splunk are like ArcSight, QRadar, they're like Dynatrace. They're things that solve the use case. So the use cases, the big use cases for Splunk are security and IT operations analytics. And the big players in security are ArcSight, QRadar, Logarithm, and Splunk, and also Elk. Then for IT operations analytics, you have things like Dynatrace, AppDynamics, New Relic, and Splunk. So you really have to think like, what's your use case on what your competitor is? Yes, the way that they manage big data, Splunk is a lot like Hadoop. Splunk has a lot of some overlap of features on Spark. Splunk has some overlap of features on Tableau. But it really depends on like what problem you're trying to solve on what you'd pick. So, yeah. Anyway, that's it.
Okay, great, thank you.
Yep, thanks guys.
Any more questions from us? I have one more question.
Yeah.
See how we can work together. I know Derek is working with you on the, so we are, data science program here. So do you think, like just now you mentioned, for the machine learning algorithm, they use Python, that package?
Yeah.
Actually, I think many of us know this package very well, and many of us, actually, our course, for instance, clustering, they actually write from scratch coding. We don't use button to like
Yep.
linear regression button.
Yep.
So we also, for you collect button, you also do the feature selection. You use some principal component analysis to analyze feature first. And then you know which feature you select to better predict. So there's some technology you have to do the data, feature selection, and the model evaluation. After you run a linear model, you have to know how the model works, and they have some of their methods. So we are pretty good educated in that direction. So I would think about what's the best way to collaborate.
So this is one of the, kind of leads back to one of the questions that I had at the lunch. So he was, I forget your name. Nick. So Nick was asking me, if you were going to hire somebody right out of university, what would you look for? Because we do hire a lot of people and I interview a lot of people. So what you really need are things to talk about. So interesting things to talk about are projects that you've worked on. And I can tell you for people that we've hired, if they have worked on a lot of projects and done a lot of things, when we hire them, we don't have to train them very much. And so they're really successful right out of the gate. So they're able to, be productive and move up in comp and recognition and status and all that really quickly. So you guys will want to be looking for projects to work on. So doing models like this would be good. Also, if you guys could get plugged into good data sets, that's really what you need. So I would think too, if we could find you guys good data sets to do analysis on, and I think Splunk could help us find you guys good data sets, and then you could use them in whatever tool you want. I mean, usually they're either CSVs or they're just big dumps of data that we get our hands on, and then you guys could use that in whatever tool you want. So I would think that those were the kinds of things that we could do. So, and then, there's a lot of things that just happen in industry that people don't even know. I was talking to Charlene on the way over here because she was asking me, like, what project are you working on right now? So I still do projects because I want to know, like, what companies are doing, and I want to know, like, if I don't know how to do something, I want to learn how to do it on a project. So I'm writing an app right now for a company, and what they do is they do persona-based, they really do stuff for ads to tell which ads are effective and which ads people click on. So what they can impersonate that I'm a 40-year-old woman from Seattle, I just bought a camera, then I went to Google, and then I went to your site and started looking at stuff. And this is what I'm doing. So by doing that, they can tell companies a lot about behavior of people and also what the site looks like to them. So that was their core business forever. Well, they also figured out that by doing that, they could tell which ads had a virus payload on the back end. So if you clicked on the ad, you really were downloading a virus to your computer. So I'm writing an app because they collect then all the URLs that have those virus payloads, and they sell that to companies. And so I'm writing an app that integrates that with Splunk because Splunk can tell you if you're seeing any activity from those sites, and so that would be threat list activity, And you'd want to look at that because that means there's probably active viruses on those machines that are doing it. So the thing I was telling her about is I didn't even realize the amount of this persona-based thing, like how valuable it is to have a persona, because they can even go down to like what type of antivirus do you have on your computer. So they can impersonate this certain type of antivirus and then go to a big company like CNN and say, okay, I'm going to look at all of your current ads on your site and also all your future ads that you're planning on running over the next week. And I'm going to come in as all these different personas. And then when I click through the ads, see how they interact with me and which ones of them end up giving me a virus payload at some point. And so they can impersonate high net worth individuals. They can impersonate, you know, a 20-year-old college student. They can impersonate all these different personas, and they do it from different locations. It's unbelievable. There's just so much that happens in tech that most people don't even know, like, is part of the ecosystem. So anyway. So thanks, guys.